Eclipses. Thanks to several hundred years of astronomical research, we now understand how and why eclipses take place. Eclipses can be classified into three categories: solar eclipses, annular eclipses, and lunar eclipses. A solar eclipse occurs when the moon comes directly between Earth and the sun so that the moon's shadow falls on Earth. The key word is directly, because although the moon passes between Earth and the sun every month at new moon, the moon's shadow misses Earth most of the time. During most new moons, the moon's shadow falls either above or below Earth. But on rare occasions, when the sun, Earth, and moon are aligned just right, the moon's shadow falls directly on Earth and we see a beautiful solar eclipse. During a solar eclipse, the darkest part of the moon's shadow cone, called the umbra, moves across the surface of Earth. The umbra is often only about 250 kilometers or 155 miles in diameter. If we look at this diagram, you'll see that the only time that the moon can cause a solar eclipse is when it is the new moon, because if it's on the other side of Earth, it's going to be the full moon. So only new moons are going to be the ones that cause solar eclipses. And again, not every new moon causes a solar eclipse. So again, eclipses can happen only when the sun and Earth are in line with the full moon or new moon. At all other times, the shadows of the moon and Earth fall into space. So we will talk about what type of eclipse happens when there is a full moon, but is not a solar eclipse. So hold on for that. Another example of the alignment of the sun-Earth-moon system during a solar eclipse. Again, the moon is in the middle. This darkest part of the shadow is called the umbra. This lighter section is still the moon's shadow, it's just not as dark. That's called the penumbra. Everything within this black section is what we would see as a total solar eclipse. And everything within this penumbra would be what we would call a partial solar eclipse. So if you're in that region, you would either see a full or a partial solar eclipse. Everywhere else on Earth would not see an eclipse at that point. People who happen to be in the path of the umbra can see a total blocking of the sun by the moon, or a total solar eclipse. During a total solar eclipse, the air cools and the skies darken. Because the moon's shadow moves quickly across Earth, the time that the moon completely covers the sun, or totality, only lasts a few minutes. During totality, it becomes dark enough to see bright stars and planets. The outer atmosphere of the sun, called the corona, is seen around the black disk of the moon covering the sun. For a few breathless minutes, we see one of nature's greatest spectacles. Outside the narrow path of the umbra, a shadow is cast, but it is not as dark as the umbra. The lighter part of the shadow cone is called the penumbra. People in the penumbra see a partial eclipse of the sun. Because the penumbra is much larger than the umbra, more people experience a partial eclipse than a total eclipse. In an annular eclipse, most of the sun is covered, but an annulus, which means ring in Latin, of sunlight surrounds the dark disk of the moon. To understand an annular eclipse, remember that the moon's orbit around Earth is an ellipse, not a circle. As a result, the moon's distance from Earth varies. When the moon is closer to Earth, it covers the sun completely, creating a total solar eclipse. When the moon is farther away, it appears smaller and cannot completely cover the sun. In this image here would be where we see the annulus, or ring of sunlight, visible during an annular eclipse. In a lunar eclipse, Earth comes directly between the sun and moon, an alignment that puts the moon in Earth's shadow. When the entire full moon falls within the darkest part of Earth's shadow, or umbra, we have a total lunar eclipse. Everyone on the night side of Earth, or half the globe, can see the eclipse. Depending on how much dust and how many clouds are in Earth's atmosphere, the moon will appear dark brown, red, orange, or yellow. This happens because light from the sun passes through Earth's atmosphere, which refracts the sunlight around Earth so that it falls on the moon and creates a glow. So we look at this diagram for a second. We see that in a lunar eclipse, the moon is behind Earth. So now Earth is in the middle of the sun and the moon, and Earth's shadow is blocking sunlight from getting to the moon. So a good way to remember this is a solar eclipse is when the sun is eclipsed or hidden by the moon, and a lunar eclipse is when the moon is eclipsed or hidden by the sun. So solar and lunar are referring to what is actually being covered or blocked. A partial lunar eclipse occurs when only part of the moon passes through Earth's umbra. A penumbral lunar eclipse occurs when the moon passes through only the lighter part of Earth's shadow cone, the penumbra. Neither of these lunar eclipses is as colorful as a total eclipse. So for example, if the moon were here in its orbit, partially in the umbra, we would call that a partial lunar eclipse. And if the moon were here in the penumbra, we would call it a penumbral lunar eclipse. Look in astronomy field guides for the dates and locations of future eclipses. The next time that you have an opportunity to view a solar or lunar eclipse, do not pass it up. Whether you watch the disappearance of the sun as the moon passes in front of it in the middle of the day, or if you watch the transformation of a full moon into an orange-red disk, it is a worthwhile experience. And below, this is an example of what a penumbral lunar eclipse would look like and where the moon would be located.